So in yesterday's session, what I have covered is I have covered peering, and we have seen how to configure VNet to VNet peering between regional VNets and also the global VNets. So, and there is one lab which is still pending. Okay, yesterday we tried to configure everything and we were not able to do SSH from one VM in different region to the region in region in two different regions. We were the VMs in two different regions, we were not able to connect. So today I have actually checked that there is one configuration while we were creating this VM, right? SSH should be enabled. So I went through the recording also where we have disabled that. But
Okay.
we just need to enable that. It was working, but I tried this morning and I have actually deleted that resource group. Um, I won't be able to show it today because I have not configured or kept everything ready. Uh,
Okay. Okay.
what I will do maybe tomorrow or something, I will try to keep everything ready and I will show that, we just need to SSH. That's one thing is pending. And today I will continue with the next concepts of intersite connectivity. So we'll see VPN gateways, point-to-site connectivity, site-to-site connectivity, point VPN gateways, and gateway transits. So these are the
Got it.
topics for today. And this is a more of a theory concepts. So we won't be doing um, labs on it, but I will show you how or from where you can actually configure them. What are the options given? These are something which we need to be creating from on-premise to cloud and all. So due to that, I won't be able to show you fully configured lab on this.
Got it. Yeah, even yesterday after the class, even I was looking for the same options, what all ports need to be enabled, and the SSH was the one port, and 443 was the other one because we were trying to access via Bastion, right?
Correct.
So Bastion ports were showing something. So I was troubleshooting some, but I couldn't get more time because I was pretty occupied this today from morning to evening. So
Okay. And the other thing which I was, was thinking of, so when we are creating this VM, right? So we enabled SSH, so that is port 22.
yes.
I think once we enable that, when we create VM, it might go ahead and add those ports into this network security group also, inbound and outbound both, because that's where I think the ports are getting blocked.
Yeah,
Uh,
usually on the network security side, even though we allow, I think the port group, we need to allow them in inbound and outbound. That's what I remember, but not sure on that part. So I couldn't do anything.
yeah. So I tried the lab this morning. So I enabled while creating the VM SSH. I enabled and I was able to do SS, you know, login to the other VMs. But I haven't gone and checked if something got added in the network security groups. Because when we were configuring this VM, right? So in that configuration itself, we were adding this network security group. So I
Got it.
was, yeah. So yeah, this evening I will try to check if something is getting added there. Then I will let you know tomorrow if those some
Sure.
ports are getting added to network security group rules are there, right? So if
Yeah, yeah.
something is getting added there, I'll check and I will let you know.
Sure.
Spearing and so today the first topic is VPN gateway. So like how we have this setup yesterday, the same setup, VNet A is having this IP range and this is in so region 1. So here this is US New York office and it is having subnet 1 and also gateway subnet. We need to create this gateway subnet um, when we want to create a VNet to VNet connection or site to site site to site VPN or point to site VPN. So this is mandatory need for configuring VNet to VNet connection and these two P2S and S2S, point to site and site to site. Similarly, from UK office, UK London office. So we have one VNet which is there on cloud, VNet B, and we have one subnet there which is of 172.16 range, and we also have this gateway subnet. So in this VNet, we have this gateway, and everyone on point to site and site to site, that is on premise, the users are connecting to this gateway subnet. So the people or the office staff, they are trying to connect to this gateway. So whoever are working in UK London, they are connecting to this gateway subnet and they are accessing the resources. And the people who are in US New York office on premise and point to site, they are connecting to this gateway subnet, which is in US New York. So on the cloud, they are connecting. So now if someone who is here in London on premise is trying to access a resource in on premise of New York office, they won't be able to connect unless until we configure this VNet to VNet connection. So we have to configure this VNet to VNet connection. To configure this, we need gateway subnets. So what all the things are involved? So to configure this site to site connection, right? So here we are trying to, so this is site to site and point to site, this. So this VNet to VNet connection, what all is needed? So VNet peering we have already seen. So this VPN gateway is needed for configuring this gateway subnet. So we'll also come across something called local gateway network. So that will actually have this IP address of the the public IP which is configured here. So that will again try to make the communication between this gateway subnet and to this one. So I will go ahead and tell you the difference between the VNet peering and the VPN gateway. So will it support cross-region support? Yes, the VNet peering will support, and the VPN gateway will also support. Cross-subscription support? Yes, both of them they support. Cross-subscription here, the Azure subscription, and cross-deployment model also it will support. Means IaaS, PaaS, or SaaS. So it will support, the VNet peering will support this, and also the VPN gateway. So what are the limits? So when you create this VNet peering, up to 500 VNet peerings we can create. Yesterday we have created only one, VNet A and VNet B. Like that we can create up to 500 VNets on a single VNet. For VPN gateway, the limits are each VNet can only have one VPN gateway. So a VNet, if you want to configure VPN gateway, it will support only one VPN gateway. And VPN gateways, depending on the SKU, have different number of tunnel support. So when you are configuring VPN gateway, it will ask which SKU you want. So this SKU is um, something where you can select the configuration. So it will have the bandwidth it will support and the configurations and all, the number of connections and all, IPsec and all the tunneling and everything we can select from that. So depending on that SKU, it will allow. Next is pricing. So it depending on ingress and egress, that is incoming and outgoing traffic, it will be charged. So depending on the gateway plus the egress is outgoing traffic, it will support. I mean, it will be charged. Encryption. So this is a software level encryption will be done here, whereas here in VPN gateway, it will be IPsec and IKE policy and applied to, so these are created and applied to the existing connections. Bandwidth limitation. So here VNet peering is, there is no bandwidth limitation, whereas it depends on the type of gateway you are using and also the leased connection you are using, or the type of connection you are using. It depends on that. It varies from 100 Mbps to 1.25 Gbps. Is it private? Yes, no public IP endpoints, routed through Microsoft backbone and is completely private, no public internet involved. So VNet peering as discussed. So this VNet peering is entirely done, and in the backbone is Microsoft. Okay, so everything is maintained and it is private between Microsoft. So no public internet is needed here. But whereas when you are configuring VPN gateway, it involves public IP and public network. So transitive relationship. So as discussed yesterday, the VNet A and VNet B and VNet C we have seen in example yesterday, right? So if you are configuring the peering between VNet A and B, then VNet A will be able to connect to VNet B. And if you are configuring the peering between VNet A and VNet C, VNet A and VNet C will be able to communicate. But that doesn't mean VNet B will be able to communicate with VNet C. Okay, so this is a non-transitive. VNet peering is non-transitive, whereas this is transitive. This will enable for communication. So if VNet A, VNet B, VNet C are connected via VPN gateways and BGP is enabled in the VNet connection, transitive works. That means even if you are configuring VNet A to B and A to C, B and C can communicate. So that works in VPN gateways scenario. Typical customer scenario. So this is something what all it supports: data replication, data failover, and other scenarios needing frequency backups of large data. So this is supported. So this one is encryption specific scenario that are not latency sensitive and do not need high throughputs. So so these are so this is something we select when we are okay with any kind of latency. I mean, this is much faster, but this is little slower. High throughputs, we don't need high throughputs. In that scenario also, we will choose this one, especially if you are taking backups or doing something that doesn't immediately require any action, or the consumers are really looking out for that particular data, right? So in that scenario, we configure VPN gateways. And how much time it will take to configure VNet peering? It won't take, it hardly takes 24. So it says 24.38 seconds what it took. So that is the best time it has taken to configure. So if you, yesterday, I think it has taken a minute or so, maybe less than that. But
Yeah.
here, yeah, so it has, so basically it is quick. And this VPN gateway, it takes quite a time. 30 minutes is what they say.
Yeah, because it need to be established the VPN gateways depending on the SKUs because of the custom IPsec, right? So the
Yeah.
encryption policies and all things which would take a lot of time to set up in background. Yeah, that
Yeah.
makes sense.
Yeah. So this takes 30 minutes. Hmm. So site to site VPN is next thing. So if you see this below diagram, so it says gateway subnet, VPN gateway, local network gateway, and on-premise VPN device. So there are four things. The first three things, right, are configured on Azure. So we'll first create the gateway subnet. So we'll first create the gateway subnet. This subnet is used when you set up site to site or point to site VPN connection. So here we are trying to set up site to site. So gateway subnet is used here. And VPN gateway is part of, when you are configuring this gateway subnet, it will ask, it will give you an option to select VPN gateway. So, so if you, it is an integral part of this gateway subnet. It handles the encryption and decryption of data. So it handles the encryption and decryption of data, keeps the VPN tunnel secure, and manages the connection between Azure and your on-premise network. So they basically, this will handle the encryption and decryption of data, and it will be secured with the VPN tunnel. So after this, there is a third one, local network gateway. This is nothing but, this is one configuration which will try to take the information from you of the IP address of your on-premise device. So that's what it says. It represents your on-premise network in Azure and stores the public IP address of your on-premise VPN device. Next one is on-premise VPN device. So this can be a firewall or a router that supports VPN, and it must have a public IP address so it can be communicated with Azure over the internet. So, so this is a firewall or a router, and it will have some public IP address. So this IP address is configured in this local network gateway. So this is something on Azure. You say, okay, go here and take the data or like that. So, so that information we should be giving here. So that's how the configuration of site to site is done. Similarly, the site point to site is also same. Only thing is, so we are also configuring VPN gateway, but in while configuring VPN gateway, so we do the point to site configuration. We say this is the IP range you have to provide to the users who are remotely logging in, and you submit the configuration. Then it will give you an option to download one small software that needs to be installed in the remote machine, the user who is working from home or who is traveling. So then this software, once we install, it will ask the VPN endpoint details. Then we need to select the VPN endpoint details. Then we will connect. Then you will be able to connect to this um, gateway subnet, and you will be able to access all the Office resources. Any questions on this?
No.
So even in this part, right, these all are covered in 10. I mean, these are just the topics on 104, but uh, there won't be any questions on that. Especially, they will be covering on gateway transit. So only this topic is something which is in the syllabus of 104, which is Azure Administrator. So this,
Yeah, I remember doing it. So that's why, and I could recall it somewhere. I heard something like that. So you made me easy instead of thinking like,
yeah. Uh, so this point to site to site are there, but gateway transit is something. So this is one scenario. If you see the diagram, so I have VNet A, which is in region one, and VNet B is in another region. VNet C is in another region. Then I have the on-premise people. Okay, now I want to access resources, and then I need to do a site-to-site VPN connection between VNet A and to my on-premise network. Then again, VNet B, I need to configure site to site, VNet C, then site to site. So many site to site connections I have to create. So this is a traditional setup. Okay, you need to create multiple gateways. Managing them is complex and costly. So managing them is complex because you have so much configuration needs to be done. Higher operations cost also. And each gateway has its own cost. So this gateway has some cost. These all are costly, and you have to pay for each gateway. To overcome this traditional approach, the gateway transit comes into the picture. So what is this gateway transit? So what they have done, they created one more hub VNet. So this is one VNet which they have created, and they are calling it a hub VNet. It is similar to the other VNets, but what they have done the peering between the hub VNet and VNet A, and hub VNet to the B, and hub VNet and to VNet C, and they have created the peering between these three of the VNets and to the hub VNet. And the peering, right? So once you
yeah,
configure VNet peering, what happens? It uses Microsoft Backbone, which is very
yes,
fast. It won't use the public network. So the traffic between VNet A and the hub VNet is much fast, and similarly from the other VNets. Now, this traffic, so suppose a resource, one of the resources is trying to connect to on-premise network from VNet B. So now till here the packet has come, the request packet, but it has to pass through and go to on-premise. From here, hub VNet, how it will go to on-premise? So at one point you have to configure site to site, right?
yes.
So that's where we configure site to site. We configure site to site between hub VNet and on premise. So
Yeah,
instead of
technically three VNet peerings come to the hub, and from hub it distributes to the from hub it makes the site to site and go to on-premise. Okay.
correct. Yeah. So earlier it was like this.
Yeah.
So it has going through public VNet. It has going to through public VNet. It is slow also, right, from there. So and costly also. So now that you know, so this is how we configure um, hub VNet. And this is another diagram which I have taken from the Microsoft Learn. Okay, so what they have done, so these are like VNet A, VNet B, VNet C. We have VNet A, VNet B, and VNet C, right? VNet
Yes.
A, VNet B, VNet C. Here they are calling three of them are spoke. They are calling one as they are configuring one of these VNet A, B, C, one of them as a hub.
Okay.
So this is speaking to this hub. This is speaking to this hub. So instead of creating a new hub VNet, they are configuring one of the VNet as a hub VNet.
Hub. Yeah.
And the other two VNets are speaking to this hub VNet.
Okay.
So instead of introducing one more new, so this is also one approach. But so this is also one option. You can directly configure one of the VNet as a hub. Okay, so the same thing they are doing. They are again configuring the peering between these two. And here they will configure VPN gateway and site to site. It can be site to site or VNet to VNet or point to site VPN. Because as we learned earlier, right? So this VPN gateway will support site to site. It will support site to site, point to site, and VNet to VNet connection. The same thing I'm showing here in just like this. This
Yeah.
is a
Got it.
tunnel, right? VPN tunnel.
Yes.
The same thing. So this they call it as a hub and spoke architecture. This is hub, this is spoke,
Okay.
hub and spoke architecture. And so what are the advantages? It is a centralized architecture, provides a single and well-organized network structure. It provides a single and well-organized network structure, enhanced security. So a firewall can be placed in the hub to inspect all the incoming and outgoing traffic. So here we can place a firewall configuration. So whatever the incoming and outgoing traffic can be, inspected here in this um, hub VNet. Reduce the complexity using VNet peering minimizes configuration errors and simplified managers. So VNet peering is easy to configure when it comes to configuring VPN gateways and all. Multiple VPN gateways is very complex. VNet peering is very simple to configure. Cost efficiency. A single VPN gateway in a hub can be shared across networks and reducing cost. Here we are getting a single VPN gateway. So that is cost efficient. And improved performance and best practices. It delivers best performance while following Azure's recommended network design principles. So this is our Azure recommended network design. So they recommend to use hub and spoke architecture.
Got it.
So yeah, this is so as said. So this is for the day and the theory. And so we'll see virtual network gateway. So from here, they will configure um, VPN gateway is one thing, and express route. I was talking about express route, right? When you are
Yes.
configuring use express route, and this is virtual WAN. I'm not sure what this is. It looks like something. So these are all cloud, and there is a middle. There is one more cloud, and these are on premises. I think this is point to site. This is site to site. Looks similar to transit. This is the express route. And they in the overview, you can see what is the difference between them. So this express route is private and direct connectivity, and the VPN gateway works on internet,
Internet.
and this is private connectivity and internet. So it is supporting both. I think this looks like the gateway transit because we have both peering and also side to side.
Yeah. Advanced.
Throughput 100 Gbps up to 10 Gbps. So these are all the different things which you can configure, and these are all some properties of Express Route VPN Gateway and virtual network. And we can set up VPN Gateway from here. So I was talking about this local network gateway, right?
Yeah.
So local network gateway, it will just, this is where you actually give the IP address of your remote device, that is on-premise device. So these are all normal configuration. Resource group name you give, region you give, the name of the local network gateway you give, and it is asking the IP address, the IP address of the device we have to give here. And it is a simple configuration, just advanced, nothing much is there. Configure BGP settings. If you have got some BGP setting details from the internet provider, you can configure and then just create. I'll go back. Mm, So VPN gateways here, give the name, and here it is giving you option to select express route and VPN. And if you are selecting VPN, this is the SKU where you can select. So each SKU has its own bandwidth support.
Yeah.
As yeah, as we mentioned in that table, right, the difference between peering and VPN gateway. So the SKUs are, let me try to check. Mm, VPN gateway SKUs. What are the configurations?
I think VPN is 100 gigs throughput, which we saw by the, okay, 100 Mbps. Okay.
Yeah, so
Oh,
these are
okay.
different SKUs.
Yeah, it's generation wise. Okay.
And SKU means storage keeping unit, right?
Yes, yes.
Yeah, so this is a basic SKU, and so these are all configuration, how much throughput it supports. Then higher the throughput, higher the cost.
Yeah.
And here generation and generation two. So these are all generation one and generation two. And what I have learned is somewhere, if you want to upgrade, right? So I am using generation one, GW1. Now I want to upgrade to some other thing. You, I can choose only from generation one, not from generation two. That's what I heard. A
Oh,
generation,
okay.
yeah, from generation two, you can upgrade to generation two.
Okay.
So these are all algorithms they are using for encryption and all. Okay, I'll go back. Uh, uh, that's it for the day, Amar. Today is a small session. Okay, tomorrow I'll come up with the other topics. Mm, Going back,
Okay.
I'll share these slides. What I will do, I'll put all these slides in one of the drive, Google Drive, and I will share the drive link. So I can upload there. You can use the same link to check.
Yeah. Yeah, that's gonna be easy.
Yeah, and tomorrow I will cover private endpoints and service endpoints. So these are some things I'm actually using and working on in the
Okay.
present. So I will try to show them. And after this, we'll go ahead with application gateways, front door, and load balancer. So application gateway is also a good topic. So I'll be covering them in most probably tomorrow, or in next 2 days we'll be finishing up this network part. Then we'll go to VMs.
Okay.
Other topics are small topics only. Key vault, container registries. Those are all small topics. So this networking is little big topic.
Yeah, that's a main core, right? So how we allow, what we do, and all the stuff.
Yeah. Okay then, Amar.
Sounds
I
good.
I give back your 20 minutes or 25 minutes today. Yeah.
Sounds good. Thank you.
Thank you. Bye.
Have a good day. Bye.
You too. Bye.